Live from the internet, it's the Localhost podcast with Mark Drew and Rob Dudley.
Hello from the internet. Welcome to another episode of the Localhost podcast Develop Branch. In this edition of the podcast, we can add features in the safety of our local development environment without affecting the normal build of the show. Joining Rob Dudley and me, Mark Drew, is Mark Mandel, developer advocate for Google Cloud Platform. Let's get on with the show. So the idea of these shows is that we're meant to branch out from the main show, but you can't blame this old git for wanting to pull in great guests and get our heads together in great conversation. How's that for a pun, Rob? How's that?
No, just no. It's too late in the day.
Sorry. Well, hello to this special Develop Branch episode. We would like to welcome a very special guest, a genius in his own time, and the incredibly talented developer, Mark Mandel.
You give me far too much credit, but thank you for having me.
I'm going to give a background on you, and then you can tell me where I'm wrong and right.
Sure.
And what have I missed out? Mark has been an accomplished developer and contributor to the coding community for more than a decade. He has developed projects such as Java Loader, Transfer ORM, as well as many others. And he's recently moved from his native Melbourne. It is your native city, isn't it, Melbourne?
Yep, you're right.
To the sunny-ish climes of San Francisco to work for a small startup called Google. What kind of name is that? That's a silly name.
I don't know. I didn't make
Welcome
it up.
to the show, Mark.
Thank you for having me. That seems reasonably correct. I'll take that.
Okay. What are you doing at Google?
So I am a developer advocate for Google Cloud Platform. What that means is I get to do very, very silly things with very large amounts of servers, get up in front of audiences and tell them about said silly things, and then talk to all those people who are in front of me through either like events or podcasts like this one, Slacks and other community stuff, and then bring all that feedback back to product managers and engineers and tell them what's good and what's bad, what needs fixing and what needs improvement.
Fantastic. I mean, it's really appropriate for you to be on the show, considering that you're working for the Google Cloud Platform after our first episode in the master branch, which was all about Docker.
Lovely.
And kind of containers. But the only reason we got you onto the show is to find out how you say Kubernetes.
I say Kubernetes or Kubernetes sometimes. I've heard both. I think originally it's Greek for helmsman. You can take it that way. I did find out recently that in Hebrew, kubernetes is like captain. Like there's obviously lots of different ways you could say it. I think as long as you use it, I don't really care how you say
it. As long as people are paying the bill, who cares how you say it?
Well, it's open source. It's, there doesn't necessarily have to be a bill to pay. But anyway, I digress.
So the reason, apart from finding out how to say Kubernetes, I wanted to get you in the show is because one of the questions I think we didn't answer fully, I think we stepped around it in the main show, was more about load balancing and how containers can scale in the cloud. Mm-hmm. And I thought, who would know more about that than Rob? But then I looked around and saw that you were about, so I thought, why don't get Mark Mandel on?
Sounds reasonable.
So tell us a little bit about Google Cloud and how it deals with containers and maybe
how
you can scale stuff in that.
I'll actually I would like, if you wouldn't mind, I'll take a little step back because I think it's kind of relevant to the conversation to sort of set some context around, I think my thinking, and I don't want to say necessarily Google's thinking, but I think the thinking of several of my peers around containers and orchestration and that kind of thing. And I think something we've all kind of come to agree on, and I think makes a lot of sense, is in some ways, the idea of a container is kind of an implementation detail. Like, I think it can get focused on a lot because of it's kind of cool and new and shiny. But I think the really big and important thing about containers as a whole is that it's a really, really good abstraction. And it's a really good abstraction basically for any type of software you want to build. Right? So any type of software you want to run, regardless of where you want to run it. So I say this a lot when I'm doing presentations, such that, right, so if I'm running stuff in containers, I don't care whether it's a Java app or a Ruby app or a Node app or CFML app or whatever it is, right? That doesn't matter anymore. And the reason that's so important is then that once I have that abstraction, for me to do scaling and orchestration and deployment and health checking and all that other good stuff, log aggregation, et cetera, I can build these generic solutions to those very common problems, right, that we all have as developers, because now the software that's running is abstracted away from what it's written in and like what technology it uses and necessarily how its internals work. So that I think is the building block, because that's what's so important. Because once you get there, then it's no longer how do I deploy my Java app? How do I deploy my CFML app? How do I deploy my Node.js app? Do I have different tools? Do I use Capistrano? Do I use Chef? Do I use Puppet? Do I use some Makefiles? Like all these different tools that built around particular languages and communities. Now suddenly it's like, oh, actually I don't care, right? My tools are always going to be the same. So that's step number one. Step number two is like, what are our opinions about those general solutions and what should they look like? That I think is the next solution. So for us at Google, we have an open source project. It's called Kubernetes. If you haven't heard of it, it's essentially like Docker orchestration at scale, or I actually should say container orchestration at scale, because you can run Rocket on it and a few other different types of containers that are still up and coming as standards as well, which I think is also really important. It is a direct descendant of how we basically run a lot of our infrastructure internally inside Google. So we basically took a lot of the lessons that we learned about how we run software and distributed systems inside Google, and then basically built a greenfield open source project based on that. And that's where Kubernetes comes from. If you want to learn more about how that came from, one of my tech heroes who I met last year, which is fantastic, John Wilkes, has a great presentation at .con. I've linked to it like a million times. I mentioned it a bunch. It's really worth watching if that sort of thing is really interesting. He talks about that.
We'll try and find it and put it in the show.
Yeah, it's superb talk. Just talking about like systems that you like, expecting failure and how to set up for it, and why we build software the way we do here inside Google. So that's the big sort of takeaway, I think. Like once you have those containers, you can build that sort of stuff, and that thing we built is the thing called Kubernetes. I can keep going for a while. I don't know if you want to interrupt me.
I'm not going to interrupt you.
Okay.
You keep on that.
That's fine. Then I will keep going. I will spiel on for as long as you'll have me.
You're the genius in the room. Man. I'm not going to keep quiet.
That's fine. So I really like Kubernetes. So Kubernetes is very much a batteries included container orchestration system. So what does that mean? What did maybe that flow look like? So so let's sort of break it down. I have a piece of software. I've written it. It doesn't really matter what it is. We'll just say it's a web app. We'll keep it stateless for now. So it doesn't store any data. Once you start getting into data, there's some other things we can talk about, but just keep it simple. I build a Docker container out of that. So I write a Docker file, I do Docker build. Depending on where you're running, right? If you're running with us, we have a container registry. So basically you need a place to put that image, a registry place that image. So you push that up there.
So like Docker Hub or Amazon's ECR.
Yep, and we've got our thing called container registry.
Maybe Google's.
Yep, exactly. So
right.
Pick your poison.
What's Google's container registry?
It's literally called container registry.
Google.
Yep.
Okay. Ingenious.
Yes, I know. We have names that sometimes make sense.
Yeah.
So yeah, you push that up there, and that means it's shareable, right? So in like say a lot of cases, say like I'm sure if you're using AWS, if you're using us, it's a private registry. So like we handle the security for you, so only you can use it. And then assuming you have this Kubernetes cluster set up, and I'm not going to talk too much about setting up clusters. That's a whole other thing. But assuming that this Kubernetes cluster set up, you're able to declaratively basically tell it what you want it to do. And I think this is also a really cool way and an interesting way of how Kubernetes works. Kubernetes is very declarative, right? So you have to be like, what I want you to do is run, say, 10 instances of this container, and I want you to run them in the cloud. And if they fall over, I want you to pick them back up again. All right, so usually you send a YAML file, their APIs, you can do it a bunch of different ways. But it's like a kubectl, and I'll write a YAML file that'll have those declarative things in it, 10 of these, this is what I want you to do. Maybe I might add, hit this HTTP endpoint for some health checks. There's all sorts of other stuff I can do in there. But I send that up to Kubernetes, and it's Kubernetes' job to make sure that those 10 instances are up, and those 10 instances stay up and running. And I don't have to do anything for that. Right? So if they do fail,
like Kubernetes will add another one
to
the...
Yep.
another container or another instance of the container.
Another instance of the container inside the cluster. And you don't necessarily know where that happens inside the cluster, and that's a good thing. It handles the scheduling, the bin packing, making sure it's using good resources across the cluster.
Right.
It's there's an idea inside Kubernetes that works, again, goes back to Borg, a reconciliation loop, for lack of a better term, which is like really simply like it's like, what do I have? What should I have? And what's the difference? Let's make that happen. So like you say, I want 10 instances. How many do I have? I have 0.
Right.
And then you just go around in circles and make the action.
So if you have like, for example, 10 instances, can you also like script it that say like, once my traffic gets this big, add X amount of instances?
Yeah, so like as a like a base level, you can just be like, hey, I want 5. You can also auto scale, right? So you can set that up as well. Right now we have CPU based auto scaling. You could do that. You could also manually, like if you wanted to control it yourself, you could do that as well. There's like, I can literally just go kubectl scale deployment, instances equals 10, and it'll just go spit those up for me. So there's multiple ways I can do that. I'm actually looking at, there's some ways you can also do node auto scaling within the cluster as well as doing like, if you want to do manual stuff as well, which is also cool. That's stuff I'm also looking at. So there's definite ways you can auto scale Kubernetes clusters that are easier and harder depending on where you're running it. The cool thing about Kubernetes, though, is it is also an open source project, right? So you can either come to us, you can go to other cloud providers, you can run it on-prem. And I think the bet for us at Google Cloud, and I think the idea we have is like basically like sort of an open cloud strategy, right? We'd love you to use Kubernetes. We think we're best in breed, but if we're not for you, that's totally fine. And the also strategy around Kubernetes is very much like we also want it to be federated, right? So if you want to run it, say, on us and on AWS, and you want to put like basically a shim right over the top, then we perfectly support that, and that is a project that you can use. You can federate, clusters. So,
right, because it's like availability zones is one thing,
Yep.
but if you say, well, Amazon, for example, one of their switches broke.
Yep.
I can now keep on using Google Cloud and I don't know DigitalOcean as well.
Yeah, so you could.
DigitalOcean probably runs on AWS, but I digress.
But yeah, you could run it on-prem, DigitalOcean, AWS, us, federate across the lot, and then just be like, we'll be fine. Or maybe there's ones that are closer to your customers, that kind of thing too. There's lots of stuff. Kubernetes is a deep project, but I feel like getting started with it is not, I don't think is a huge learning curve, at least from my perspective, but it gives you a huge amount of flexibility. The other thing that I think is also really awesome is there is definitely the ethos in Kubernetes of like, you really shouldn't have to change your apps. There are definitely optimizations you can make, but basically if you can run an application, then you can run it inside Kubernetes. Like if you want to take WordPress and put it inside Kubernetes, you can do that. And I know people who have done that.
I think one of the problems that I came across Kubernetes, and I've got to come clean, I've barely looked at it. I opened up the URL and looked at that. I haven't deployed anything on it. Is that as with many cloud providers, and this is taking a step back, everyone tries to define their things in different names. Like Docker has droplets, EC2 has got all the worst language in the world to define anything. And I think when I looked at Kubernetes, it had another way of defining what containers were, what permanent storage was.
Yeah. So
I think that's the only hump that it really is, but it's just a language thing.
Yeah, I mean, to sort of break
naming convention.
Yeah, to break down the vocabulary a bit. So like at the lowest level, we have what we call pods. Now, pods aren't containers. Pods are groups of containers. And I think that's a very valid point because often your application, like this is where I try and step away from containers and I try to talk more about applications because an application may be a series of containers working together. You might have your app that is written in some language, and then maybe you have an Nginx thing that attaches to that does all your HTTPS endpoints that's shared around. Maybe you have another container that does all your logging aggregation that gets attached to, right? And so you clump these things together, and that's what forms what's essentially called a pod. If you want to control...
In a way, kind of like the Docker Compose file. Like I'm just saying like that because the Docker Compose is defining your application, right?
Well, no, not exactly. So a pod is more of a group of containers that work in concert, whereas I feel like Docker and Compose, you're going to have like your database that connects up to your thing, right? So within a pod, they share a network namespace and they can also share volume amounts as well. So this is where like you can use the abstraction of containers to build basically useful tools that for reuse, right? So you want HTTPS across a bunch of stuff. So you just build what we call a sidecar, which is basically, hey, anything that's exposed on port 8080, and then tell me what SSL certs to put in through something like config maps or something like that, which is basically a way of shoving files and stuff and environment variables inside other containers in a nice way. And then like I'm just going to expose anything that's coming through that particular port through port, what's SSL, 413?
443.
443, there we go. And I'm going to expose whatever else is running behind me. Now I can put that in front of a Node app. I can put that in front of a CFML app. I can put that in front of anything that has HTTP.
Oh, I see.
So you can do some really neat things. Or you might just be like, oh, I'm going to track any logs that come to this particular spot in this particular container, or even configurable, and then send them off to FluentD or some other sort of log aggregation type thing. So you can build these nice things that work together. It really and it is important that because they share network namespace and they can volume mount the same things. So you can really build these nice, cute little abstractions of an application. And when I say application, I mean like I have my Node app with these other sidecars attached to it to do important tasks that they might need. Maybe you need a really close like memcache node that comes along with every container. Like you can do cute stuff that way too. Cool. So you got pods. Next, and there's more stuff, but like generally next level up is what we call deployments. Deployments is fun. So deployments create things called replica sets. And replica sets, they are the thing that say how many of these pods are running, and like you might tell them 10, you might tell it auto scale. It's kind of up to that. The cool thing about deployments is actually that you can change them on the fly, which is super cool. So if I'm like, hey, deployment, you were doing this image here, V1, but now I want it to be V2, it'll do basically server-side diffing and then appropriately make that change without downtime, which is super cool.
So it's going to the green-blue kind of deployment.
So by default, it does. I feel like it's a rolling deployment. But if you want to do green-blue, we can talk about that in a bit as well. Green-blue is actually super easy. So, and then we have services. Services are essentially load balancers. So because you've got containers, right, and they're running across a cluster, and you don't know where they are at any given point in time, and essentially they're ephemeral, right? So their internal IP addresses change. How do I know what to connect to? So you create a service, and a service will connect to those pods inside that deployment, which is the replica set. Now, what's super, super cool and a really, really nice abstraction is there's no direct relationship between a service, so your load balancer, which may be internal or external, and the pods that are running. So how do they know about each other? So it basically has a really cool, nice abstraction called labels. It's just arbitrary metadata that you can place on pretty much anything, actually. But in this case, is running containers. So I might say something like, my application has role of web, right? Those are my arbitrary key value pairs I can add to it. And then any of the containers that I have running with those labels, right, any of those pods, that says anytime they fire up, that just says role web on it, and that's cool, and that's great. And then within my service, I basically add a selector. So the selector is what labels should I be exposing? So I might put role web, that's my selector. So it's going to go hunting for any pods that are running that have role web on them, and it's going to expose them to the outside world. The service doesn't actually care where those pods came from or who runs them or like how they got created. It just knows I'm going to go hunting for anything that has these labels. So that's super cool. So if you don't like, say, how a deployment works or like a replica set works, and you want to really manage pods, which I've done, or just do all sorts of weird and wacky things, you can totally do that. To go back to your point, like for red-green deployments, this becomes really, really simple because you can have a service that just says, hey, I want role web, color green. And then so all the containers you have up and running that have color green, you're like, that's exposed through your service and everyone can use it. Then you might fire up the new version, right, a new replica set, but that's still role web, but that's color red, so that's not going to be on the service. You might do some smoke testing, maybe put another service on there temporarily, maybe get rid of it later. And then when you're ready to flip, you just go to your service and you're like, okay, let's change your selector around. Let's just change it from role web green to role web red. Let's say that 3 times quickly. Role web red. And then as soon as it flips, it'll be like, oh, now I'm just going to point to all these other containers. So you can get really nice flexibility there using that nice labels abstraction. And you can use that everywhere across Kubernetes.
And could you add something like checking for logs, you can have like a canary type of deployment.
Yeah.
So that you have like one server that's going out, and if it passes, you put a certain amount of your users on it. If it works, then deploy it.
Yeah, so that's an interesting one when
how
you
would that
start
work?
doing traffic splitting. When we get into traffic splitting, what I often recommend people do is basically the load balancer by default in front of Kubernetes is just a network load balancer. So it's a L4. So it's basically a TCP connection. There are ways you can do L7 load balancing, so HTTP. I think I have those numbers the right way around. Someone correct me if I'm wrong. I often get those mixed up. So if you want to do HTTP load balancing, you can. So often what I actually say is if you want to do like traffic splitting, what I'd actually recommend is you have your service, have that point to like Nginx machines or something like that, something that'll do that traffic splitting for you, and then have those Nginx things basically go route out to other services right from there, which is not particularly difficult. The cool thing is services internally to Kubernetes, you get internal DNS records based on those names. So they're very easy to do service discovery internally inside Kubernetes. You don't have to go like find the IP address or do anything crazy like that. So to set up traffic splitting, like using Nginx, like in some cookies and bounce that around should be relatively trivial. But it isn't necessarily something that's built in directly into Kubernetes.
That's very interesting. I mean, it's a way that we have to think of splitting out applications now is completely different. Then it starts becoming so much program.
Well, so
much
you
programming,
don't have to. That's just something I also talk about. Like I know, like we all talk about containers, and we tend to talk about microservices at like the same time, right? And those things get inextricably linked. But like I want to say like you can run WordPress inside containers on Kubernetes, right? If you just want to have containers on Kubernetes, all right, that point to probably a managed like MySQL instance. The things it'll still solve for you is like if one of those instances goes down, it comes back up. If you want to deploy a new version, it's really simple. You know your artifacts because you've got a tagged Docker image, right? Log aggregation sorted for you across the cluster, right? So you still solve a lot of really good problems. You don't have to jump to microservices to use containers. They're useful, don't get me wrong. But if it's not the right tool for the job for you, or you just want a slow path to moving to this kind of a thing. And there are still wins to be made without having to go full-blown microservices, distributed systems, and the inherent complexity that comes with that.
I think the big problem and the thing that always comes up is when I talk to people about Docker and containers and all this kind of stuff is when they start going, yeah, but it all disappears. It's like, what about the file that I uploaded?
So use the CDN. Use persistent file storage for that.
Right.
That's where it should go.
Exactly. Well, I mean, the CDN should be for a lot of like static assets, right?
Yeah.
But what about, let's say you're making a dating app or some app that the user uploads stuff.
That's
let's say a Facebook type.
Yeah, but that's you're doing like image uploads. That should go to a persistent file storage that's hosted somewhere on a cloud that is fronted by a CDN. Like that's where that should go. Like that's where that data goes.
Right. And this is a standard solution, right?
Yeah.
But how does Kubernetes handle that?
So I wouldn't say that's actually a job for Kubernetes. I mean, you can do volume mounts. You can totally do that if you really want. And that's probably more for data storage. I would send it more that way.
Okay.
If I was doing anything that is front web facing, I would so Google Cloud, we have cloud storage. You could then point to it and it acts like a CDN. You can actually make it a CDN on the front of it. But like if I'm doing user assets, like I feel like that shouldn't sit on a hard drive. That stuff is like scary important and should sit on some sort of redundant storage that's hosted in the cloud, right? On multiple regions and like all that kind of stuff. So
well, that's your opinion. I mean, depends who you ask.
Yeah,
because a lot of people go, "This is really important. You can't put this in the cloud."
Then fine. Don't put it in the cloud, right?
I jest,
yeah, but like
right.
set up a GlusterFS cluster or an NFS cluster and set that up like external and make it so that it's got edge caching and like do all that sort of right stuff. Whether it's a redundant storage in the cloud or whether it's your cloud, like that's fine. But that's where I feel like that data should really go.
Oh, it has to go there. I mean,
Yeah.
I do agree with you. I was taking the devil's advocate
Yeah,
situation. We have a client that actually has something like 60 terabytes of data of user files, so to speak.
Yep.
That need to be put into the cloud. We're still waiting for the big truck to drive in front of the office so we can just offload these massive hard drives.
Hard drives via UPS or FedEx or whatever is sometimes the fastest bandwidth you're ever going to get.
Yeah, it's the biggest bandwidth, especially when you've got like terabytes and terabytes.
Yeah.
So you can upload this. Yeah, we're syncing a few gigabytes a day.
Yeah.
It'll take a while.
Like, sending a hard drive to a storage location that has direct peering to whatever your cloud provider is definitely sometimes the best bandwidth you can ever provide the world.
Some provider maybe is Amazon. I'm sorry, I'm not plugging Amazon at all.
Yeah.
But they have a service that has a name, and I'm forgetting it at the moment.
Yeah.
That is literally, we will send a van, not a van, a articulated lorry outside your house that you can plug your Ethernet cable in.
Oh, nice.
To actually travel.
We have some partners for doing like actual direct hard drive import and stuff. It's fun. So, Rob, were you going to ask a question? I heard you speak.
I was, yeah. Realistically, this is kind of taking it back to the exact opposite end of the spectrum, right? So we're up there, we've got data center scale. That means we need trucks to pull our hard drives in, and we've got containers flying around, and we've got elastic storage, and it's all amazing and what have you. Now let's flip this back to the exact other end, where we've got devs possibly listening to us, probably not listening to us. And they're aware of what Docker is. They've done some digging around. Docker has a fairly low kind of barrier to entry, right? It's fairly easy to get started with.
I think so.
What is the route to getting started with, say, for example, Kubernetes as an orchestration layer? What's the best way that people can kick the tires on this thing and see how it works, how it's actually going to operate within their kind of framework?
No, that's fair. So I would first say get comfortable with Docker. That is like the first step. So even if it's just like Docker Compose or small app, or get something happening on your command line, just so you feel comfortable with that. If you try and jump into Kubernetes before you do like containerization of apps, I think that's going to be a bit of a problem for you. From there, so if you want to run Kubernetes locally, there is a wonderful little project called Minikube. You can do that and have a little cluster running. Yeah, it's cute, Minikube. There are a variety of courses. There's actually a course that's run by, is a Udacity course that's run by a couple of teammates of mine, Carter Morgan and Kelsey Hightower. It's on Udemy. It is a fantastic intro to Kubernetes and a great way to get started. I need to check. I feel like it's free. But I don't want to be quoted on that. I will actually type it in real quick before I lie. The documentation for Kubernetes is not terrible. There are places it could be better. That's basically how I ended up learning it, and I found that here we go. Scalable microservices with Kubernetes. That's the one. Yes. So scalable microservices with Kubernetes by Google. It is a free course. Timeline of it says approximately a month. I don't know how long it actually takes. It is really good. It is really, really good. I highly recommend it. If video courses are your type of thing. The Kubernetes docs are good. There's a Kubernetes Slack community that you can get on that is very, very active and has a lot of people who work on Kubernetes inside it. Those are definitely all great stuff. I would start with just kubernetes.io. There's some very basic tutorials in there. I actually haven't looked at the getting started guide in here for a while. But yeah, it's got Minikube and just really start basic, let's get this thing up and running. If Minikube has any issues for you, I don't want to necessarily make it a sales pitch for Google Cloud. You don't have to stay here. But if you want a cluster to just start up and just have no problems with, you can come to us. There's a free trial. It's $300 or 2 months. You'll hit the 2 months well faster than the $300. And then you can basically just come to us and be like, I want a cluster. How many nodes? 3. Press button start, and I'm done. And then we have all the tooling. So if you're wondering if it's gonna be a good fit for you, but you don't want to get caught up with do I need to go through how I create clusters and do all that stuff, which is kind of ancillary to how do I build applications on it. That's also a really nice way to get started as well. Was there any other resources I didn't mention that you want me to dig up?
And I'll put some in the show notes whilst you're talking. One of the things that I think it has to be said is that a lot of this containerization not sure what to call it, idea, is that it's not so much you have to write your applications for it. As a developer, you don't have to write your applications for it. It does help if you do some things such as separating out CDN or assets that could go on a CDN and things like that, separate your application
Making
out.
your container stateless is always useful.
Right, and I think that's the first step. I think that this is the big question of making it stateless, but how about data? Your standard LAMP stack. For example,
So this is a super interesting topic. The advice I would give at this stage is very much okay. So let's talk. There's two ends of the spectrum. There's what's happening in this space, and then there's like, hey, I want to run a production system. So I would say production system. All the tooling and replication and backup and logging of like VM run or managed solution databases is way better than what it's at for containers. So if you're running a production system, I would probably advocate that unless you have a very specific need to run, say, like if you're doing like a lot of microservices type stuff and you want to run a lot of small databases, or maybe not necessarily small databases, but databases for microservices that you can spin up and down and scale and do stuff with. Unless you're doing that, like say you're just running like LAMP stack, exactly, I would stick your MySQL database in wherever it is now. So like a managed solution like RDS or Cloud SQL, or if you're managing it yourself on a VM, something like that, I would leave that alone. The other side is there's a lot of stuff going on in this space, and it's very actively being looked at. Kubernetes in 1.5.2 literally just included what they call now stateful sets, which makes it a lot easier to set up things like databases where you don't want those IPs or those domain names sort of to change like ever, right? So it's not like a stateful thing where it just goes down and then it comes up and it might have a different pod name and oh God, what do I do? This is like, it makes sure things stay the same, and it's actually really, really cool. Like it's really cool and makes that stuff really simple. So there is active work happening on it. And I think we'll see it expand and continue to improve. And it's way better than it was even 6 months ago. But if you're like, yeah, I just need a MySQL instance and I want to run production stuff, I would keep it off Kubernetes for the moment, or basically any container system for the moment. I think that makes far more sense because the tooling for just keeping that running and making sure it stays up, and if it falls over, it is so much better right now.
Right. It's kind of weird because I've been using Docker for databases, exactly.
Yeah, and you can
I have like weirdly, well, for development, not for live, because it means that I have, instead of this massive MySQL database, which is a certain version and is whatever. I actually just say, hey, I'm going to map all the data to my project, or to not the root of my project, but I digress.
A local folder or whatever.
Like the data folder of the project. Start up the database, start up the web server, start working on it, and then when I switch to another project, it's like, great, I don't have this random database running in the background for no reason with weird data that I could possibly
or a local install that you don't want. Actually, I was tweeting about this the other day. I was having an interesting conversation with myself where I'm doing a project right now. I'm doing some game stuff, and I'm running Redis for doing some persistence and basically has some nice operations around data structures. And I was like, normally, like when I write tests where there's database operations, what I like to do is mock out the data operation so it doesn't hit a real thing. Often it's slow, right? And then I was like, or there's like data that just gets left lying around, and like it can get icky. Like you can do it, and there's pragmatic reasons why you would, but like often I like to kind of mock it. And then I was like, wait a minute, my Redis stuff is happening inside a container. If I shut down my container and I start it back up again, then my state is always going to be back to zero. Do I need to mock here? And it was sort of an interesting conversation.
Well, yeah, you're resetting,
Yeah,
well, this is a conversation actually that goes on quite a lot. I've been asked about this. If I'm writing tests of accessing a database, do I have to write the data in the database? Now, before it was like, well, if you have one big MS SQL, I'm looking at you.
And that's an interesting thing,
because that's a big thing, right? Do you test that? And then you're going, well, you've created the column. The column is in this perpetual state. Is either you've added it or you haven't. So the test is only used until you've added the column. after that test is useless. It will always pass. There's no state that it will not pass. And if it doesn't pass, then the database is gone, and your issues are much bigger than passing a test.
Yeah, and it also this is a whole other conversation because there's a certain amount of pragmatism. Like if it's just faster for me to do this for now because I have a deadline, so I will. But maybe my tests are now running super, super slow. So if I mock it out and basically mock the persistent in an in-memory type system, do we end up in the same place and I can get my test run faster, which makes me iterate faster. There's definitely lots of pros and cons. Also, I'm using Redis that is super, super, super fast. It's fine. It was actually a really interesting Twitter conversation, but there are certain things that, because development environments, containerization, the ephemerality of whatever you put inside a container can be used to your advantage for local development as well. Maybe you just go, we're gonna hit MySQL every time, but every time we start up a test, we start up a new MySQL container that's not volume mounted, so wherever that data goes just disappears, and that's okay. So there's far less issues, if you want to run concurrent tests or different builds running at the same time. Previously, you might have had a single MySQL instance that all those tests were running against, right? Spinning up and spinning down MySQL instances was really tough. Now it's actually really, really simple and something you might do on a regular basis. So there's some interesting changes that happen because of that.
I think developers need to get used to a little bit to that, and this is where Docker actually I think comes in a bigger space, because before you used Vagrant, and that was a whole enchilada of getting your
VMs.
Development environment right with a VM. I mean,
it worked.
In all honesty, Docker has VMs, right? And it worked a little bit because people then thought about how you're building your environment. You had Puppet or Chef or whatever to build that. But now it's even less. You just go, hey, I'm just going to use Lucid. There you go. I've done it. I don't have to install it on my machine. I don't have to install Java on my machine. It just does it. But and that brings me on to another thing, which is now you have all these VM images, not VM images, but these images of container filling up your hard drive. I have to empty out my laptop every so often because if you look at the Docker cache folder, it's just filled with stuff.
So I'm super happy now that I had aliases for this in my ZSA shells and stuff for clear out all the images that no longer have tags and all the running containers that have stopped that I didn't run properly or didn't die properly. But now the new version of container, you've got Docker prune statements.
Oh really?
Yeah, so you can just have those run on a regular basis. So if you're continually building images, you just end up with this backlog of stuff that's just not tagged because it's just old stuff that isn't getting used anymore. So it makes it much easier to clear out that space as you need it, which is super, super useful.
This is one of the things that I saw in our Jenkins build, which was delete all of the images and shut down all the containers and delete everything each time we build. So why is this here? Because we forgot to do that once, and then we did 100 builds, and the machine kind of keeled over.
Yeah, but there are good reasons for keeping certain images around because you can make build stuff faster. Because Docker is a layered file system. So if you are building on top of say Debian, which is 180 megabytes, I think of something like that, and then you add a layer on top of that. If you next time you go to build, it's not going to have to pull down Debian all over again. You just add a new layer, or you're adding just an extra thing to the program you already had. It doesn't have to rebuild that. It comes from cache. Really, yeah. But it's pretty easy to actually just find all the untagged images. There, if you just Stack Overflow it, you can find a bunch of scripts for doing that kind of thing, just clearing out stuff that's untagged and not being used by anything.
I have a question, which is not directly related to all of this, but you've been doing game development now.
A little bit.
What is it like? Sorry?
A little bit.
A little bit. What is it like coming to game development, having been a server-side developer?
Oh, so this is an interesting one. You want to talk culturally or technologically? Because I could go on for a while.
Well, I mean, let's start. Well, whichever you prefer.
So if you want to talk culturally, I did another podcast with a guy by the name of Chris DeLeon, GAMKEDO, where we talked about cultural differences between web and DevOps and game culture. I'll let you go listen to that if that's something you want to talk about.
I might or might not have listened to it already.
You might have done. That was fun. That's what happens when you tweet thoughts out at I don't know when, and somebody says yes, that's a fantastic idea. So it is interesting. So I've been focusing on game development for probably the last 6, 8, 10 months, something like that. Back at university, I was yes, I need to become a game developer. And then I was in Australia and read about work-life balance and decided that wasn't a good idea and web was much easier. And so I ended up doing that. But as I got older, I got much more interested in like how games work and like how people make games and even just playing games more. And so sort of when the opportunity arose in the role I'm in now to kind of get back into the game industry and start learning about this stuff more, I kind of jumped at it. So yeah, so I've been doing a lot of stuff around infrastructure for multiplayer games, especially, and how to host multiplayer games. And I've been doing stuff with Kubernetes for that too, which has been super interesting.
Which is precisely what you'd want it for, right? This is the one thing that you're going to have massive scale up for the release of the game, and then it's going to drop off.
So it's interesting. I have found that the game industry is not necessarily... Now, I say this with probably some bias because I do live in a bubble. I live in San Francisco. But probably is up to speed as on the cloud and like infrastructure stuff. And there's pockets where that aren't true. But as say web or DevOps, like type of culture. So containerization, things like Kubernetes, that's like right at the bleeding edge for game companies. Not all of them. I mean, like obviously I've done podcasts with Niantic and they've talked openly about how they do Kubernetes. Actually, CCP.
But Niantic.
Sorry, go on.
Well, they are ex Google, are they not?
They were, yeah. Well, they are.
Yeah.
So Pokemon Go, CCP, the people behind Eve, they've also talked about how they run a bunch of services on Kubernetes. Not their simulation, at least as far as I'm aware, but they run a lot of their services there. So, I mean, there is some uptake there. But like, say I go out to, a game conference and I want to talk about cloud, I have to come in at a different level, which is fine. Like, I'm perfectly happy to do that. And some of the work I'm looking to do this year. So it's interesting. And also, like, generally speaking, so dedicated game servers run at a much different sort of performance level than what us as web developers are used to, right? 16 milliseconds either way is a really big deal. Right. So that's lag. That can get me or not get me a kill in like Counter-Strike or something. Right. That's important. So making sure you manage that in an appropriate way is very important. But yeah, working on running dedicated game servers inside Kubernetes right now, which is super interesting, and again goes to talk about how well Docker and containers is a good abstraction. In that a lot of the infrastructure that a lot of big companies that run this stuff have to hand build, I didn't have to do to make this thing happen, to make containers run in the cloud. So I've got like a really simple matchmaking service, and I've probably got like a 300 or 400 line piece of code that basically just manages spinning up game servers and then telling me what port they run on, right? And I can now auto scale that across clusters super easily. Basically because Kubernetes tracks how much resources each container uses, or I can actually tell each container how much resources it can use. So it's very easy for me to add and remove nodes based on whatever metrics I want. It's very easy to spin up and spin down like instances of these game servers. My deployment strategy is handled for me because they're all containers and they're tags. They've got version numbers and names. My log aggregation's already done. My health checking's done, right? I don't actually use a lot of that. Like we were talking about, like services and stuff. I just run these pods, and they're just containers.
Right, because you don't have to actually maintain the state and check for cheating and actually do the the ops side of the DevOps side. You're making a game.
Yeah, like that's all.
But
contained.
these are things that you would need.
Yeah, I mean, like generally speaking, like a lot of game companies will like they have a cluster of VMs, and like a game comes in, and they start up a game on a process, and they manage it itself. And they know how many like processes of that game server will be running. Maybe they pool them, right? This is all stuff that they have to build. How do they know how many they have? Where do the logs go? Where does it get like this is all stuff I just didn't have to do. And so even though like I'm guessing a lot of people who listen aren't necessarily game developers, it kind of just goes to show like, yeah, Kubernetes is built a lot for like web style apps. But if you want to do something that's out of the box, the abstraction makes so many things so much easier that it's really lovely.
And again, the performance, I should ask this. I mean, you're coming out of Google, so the performance is going to be good, right? But do you, compared to bare metal, are you getting any?
It's like minimal.
Is it?
Yeah, so it's really minimal. Like so.
Yeah, but remember that minimal, it could be that headshot, right?
Yeah. So the nice thing is, so this is the other cool thing, right? So with containers, you share a kernel, and that's I think a really big thing, right? VMs, they run their whole operating system. You get this whole other level of direction. Once your process is running, you're running on the same kernel, right? You're basically exactly the same layer. Network speed's an issue with like game servers. So what you do is you actually run it on host networking. So you run it on the same network as the machine that you're actually on. So like that's another big thing, right? If you wanted to run Kubernetes on bare metal, you could totally do that. And if that gives you savings, that's great too, rather than possibly running it in the cloud. Really depends on your game and like that sort of stuff too. And you can get great performances out of VMs in the cloud as well. So there's room to wiggle there. But yeah, the difference there in speed is very negligible, and it's actually really impressive, the sort of stuff you can get done.
Awesome stuff. I don't have any more questions for you because you're vastly entertaining. And
I can talk about this for hours and hours. But at some point, we will have to finish.
Just run out of time.
I've got one, which is
awesome.
Super open-ended. I mean, we've kind of talked about how fast containerization has emerged and how quickly it's come to dominate as a really successful abstraction. The tooling is moving at 1 million miles an hour. It seems like every day I'm getting new release notifications for this, that, the other. Kubernetes is already at version
5.2.
5.2?
Yeah.
Yeah, that's crazy. Right, so, okay. So the question is, and there is a question here, where's this going? I mean, what's the next big step look like in containerization?
I don't know if there is necessarily a next big step. I think it's really just good, solid iterative process. I think we'll see a lot more work happening. We're talking about like running like stateful stuff, so databases and like on containers. I think that's going to happen progressively. The things I like a lot as well are projects like Helm, which is sort of like the package manager for Kubernetes. That's moving along really well. So that basically, you can say, hey, I want a Mongo cluster, and you just go Helm install Mongo. And then if you need to update, you just go Helm update. That sort of stuff I think is moving. But I think there's a lot of stuff happening very quickly, but if you kind of get down into it, it's all stuff that's incremental in its release cycle. It just happens to be happening fast. So I don't know if we're going to have another big kaboom. I think it's just going to be a lot of really good work for that kind of stuff.
Until we hit the next pain point, I think people are going to be moving onto this. And then the next pain point.
I don't know. I look, I could be wrong, and like I can't see the future, but I think we'll be in this paradigm for a while. I think it'll continue to mature and evolve. I think it'll be a while since we see a new thing. I mean, the only other direction I can see things moving into is like the serverless, quote unquote, and I think those might just run side by side for a while. I don't think they'll necessarily have a winner, but that's a whole other conversation as well.
Awesome.
Cool.
Thank you, Mark. You've been enlightening, entertaining, and extremely awesome. Thank you very much for coming on the Localhost podcast. I wish you well, and I'll see you in the next show, hopefully. We'll have you again.
Hopefully see you in person at some point. That would be lovely.
Yes, that'd be great. All right, guys.
Cheers.
Thank you very much.
See ya.
Good night.